do that. Thinking back, remember your final is coming up, which will cover the whole first semester. Part of that was solving equations. This one doesn't really look familiar, but I think if you just follow what that means, what solving or solution means, I think it's fine. So what would you do first? Okay, he said get the x's on one side. I agree. And when you do that, even maybe before you do that, you notice that these cube terms cancel, right? So if I subtract an x cubed from each side, it goes away. And now we're down to squared, which is called quadratic. And what's our strategy for solving quadratics? Okay, well, we could try square rooting. What other methods do we have? Yeah, let's try that. So I'm canceling these two on the left to get this equal to 0. And so everything is moving to the right. I'm just going to write it the other way because I personally like it better that way. So in other words, all of this, I'm just switching to the left side. Okay, 5x squared, and then negative 2 plus 7, that's plus 5. And then negative 24 minus 6 is negative 30. Okay, so we have it set equal to 0. In fact, we always did that unless we didn't have this x term. So if the x term wasn't there, then we could avoid setting it equal to 0. Otherwise, we always did. So it's a pretty safe bet to try that at least at the beginning. Okay, what's our next strategy? Let me write some steps over here. Combine like terms. Set equal to 0. Okay. In terms of solving quadratics, what's your next option? What was it? Yeah, good job, GCF. Which is helpful regardless what we're going to do next, right? Whether we factor or if we do the quadratic formula, finding the GCF is going to help us. In this case, it's 5. So pull out 5 and get x squared plus x minus 6. Okay, next step would be either star or quadratic formula. Now you could also complete the square if you're somebody who likes that. It's a good method. We can ignore the 5 because 5 can't be 0, so it's gone. And then let's set up the star on the inside. Where the top is A times C, bottom is B, sides are A. Okay, what is A times C in this one? Just on the interior part. Okay, B, 1, and A is 1 also. Are there factors of negative 6 that add up to positive 1? Yeah, so 3 and negative 2. Okay, now we reduce, which is already done because A is 1. And top number goes with X. Other number we just write with its sign. Top number with X, number with its sign. And now we just set each factor equal to 0. By now we're really good at this. And we get 3 and negative 3 and positive 2. Okay, how'd that go? Okay, quick question. What if the cubed had not canceled out? What options do you have there? Yeah? Okay. So we're going to add, We're going to add that into our list after GCF, but before, seriously, why is it doing that? But before we star. So we'll GCF. I mean, you're not going to always have one, but just check for it. Then we're going to add this. If it's greater than second degree, which it will be for this unit most often, then try factoring by grouping. We learned that last week. That's not going to happen very often, but keep an eye out for it. Or repeated synthetic division. Okay, and then once we get it down to a quadratic, once second degree, then we'll do star or quadratic formula. Okay, that's pretty much lays out the rest of the week. Now, I do need to tell you when I'm saying lays out the rest of the week, this is the process we're going to work on. I'll add the step of graph at the end, like we have been doing. In order to do step 4, I need to tell you 2 theorems, and that's what we're going to learn today. And one of them's easy, the other one's kind of weird, but it's very useful. Before we do that, though, let's look at some of your homework problems. And which ones do you want me to do? We'll check all of them. Which ones do you want me to do, though? Okay. Okay, so we'll start with 2. We were given a 0. We could try factoring this by grouping, but remember when you factor by grouping, the thing inside parentheses has to be the same. And here I see a 5 floating around, and here a 2 and an 8. Are we ever going to leave in parentheses the same thing with that combination? No. So that means, just like we wrote a second ago, that means we're going to take this to synthetic division. And I don't need the plus there. To -8. Okay, be careful. I told you that the formatting for this is kind of stupid because it looks like we should bring that -2 at the end. It's not, right? It has that comma. And now we start synthetic. Bring down the 1. Multiply, we get -2. Add, we get 3. Multiply, we get -6. Add, we get -4. Multiply, we get 8. Add, we get 0. And because we were told that that was a 0, if you didn't get a 0 remainder, then go back and fix it because you're supposed to. Okay, so we have a factor of x plus 2. I want you to write the factors because part of the process will be writing in factored form. So x plus 2 is our factor. Maybe I'll write factor there. All right, that means we're left with a quadratic that looks like that, x squared plus 3 minus 4. And we're going to go factor that star. Just to save time, I'm going to tell you that this factors to x plus 4 and x minus 1, which becomes what when we do zeros? Okay, so factored form, we're going to get, this was g of x, we'll get the 1 given, so x plus 2, and we have x plus 4 and x minus 1. Okay, our zeros and multiplicity is kind of easy for this one. So our zeros were -2, -4, and +1. And the multiplicity was 1 for each of those. And it's because each one only shows up once in our factor list. Okay? All right, to graph this, we need to know the end behavior, which is what? Close. This is odd positive. So which one is it? That one. Okay, then we go plot zeros. We have one at -2, one at -4, and one at +1. We know it's going up there and down here. And there's no special, in terms of each zero, there's no special behavior. It just passes through each one, something like that. I missed that last one. There we go. Okay. What's the y-intercept for this? -8. So go label that. That was a quick walkthrough, but that was basically the process that you need to do for each one of these. So find all the zeros, which means you have found the factors as well. Use those factors to find the multiplicity. Use the multiplicity, zeros, and end behavior to graph. 2. All right, next you said 5, I think. All right. We're told that 3 has a multiplicity of 3, which means divide by 3 times. Okay. So negative, oh, and I haven't mentioned this in a while. Remember, if a term is missing, make sure you put a 0 there, because if you don't, it throws off your entire division process. So this one is fine, but I did see that on the quiz some. All right. What goes in the box? Is it 3 or -3? It's 3. So be careful how it's given to you. So 3 is a 0, which means the 3 goes in here. If we were told something like this, x -3 is a factor, that's the same thing. Now we would put 3 for that as well, okay? I'm just finished writing this statement. So x -3 is a factor 3 times. Anyway, let's go do this. This ought to be a pain. We'll see. Yep, like I said. 168, but negative. And then not negative, but positive 12, 36, 18. Something went wrong. 90, it's because I subtracted. Cool. Okay, when you find a 0, remember not to start over. You don't want to go back and start with the initial setup because we had a 0. It already worked. It broke it down. So we just keep going with the same, what we ended with this on the last one. Okay, drop your -2 and then multiply, add. -42, -30, -90, 0. And we expect to find zeros 3 times because we were told that it was. So this isn't surprising. Why are we doing it then if we were told that 3 is a 0 3 times? Why do we have to go do all this division? That's a good thing to be able to put into words. Like, why am I taking time to do all this if I already know that 3 is a 0 3 times? Eventually. Good. What were you going to say? Yeah, we got to break this thing down from 5th degree to 2nd degree so that, like Sophia said, so we can find the other zeros. Okay? Okay. So we weren't surprised, again, by any of that work, but we just had to do it so that we could see this quadratic. Now we can factor -2x squared plus 8x plus 10 and find those other 2 zeros. Okay. Pull out your GCF. Remember, anytime x squared is negative, you want to pull that negative off. And -5. There we go. Okay, if we star this, we're going to get x minus 5 times x plus 1, which gives us what zeros? Yeah. All All right, zeros and multiplicity. Make your little brief chart. Our zeros are 3, 5, and -1. What's the multiplicity of 3? 3. What's the multiplicity of 5? 1. And -1 is also 1. Okay? And I didn't write factored form. I'll have to do it up here, I guess. So j of x equals negative, don't forget your negative out front, x minus 3 cubed times, by the way, it's -2. I need to put that out there. I have to move that whole thing. -2, x minus 3 cubed, x minus 5, x plus 1. Where'd I get the -2 from? Right there, the GCF, okay? So make sure that your factored form matches the end behavior of your given equation. All right, what is the end behavior for this one? Odd negative, right? So this version. All right, zeros, we have a 3, we have a 5, and a -1. We know that it's going to start here and end down here. So linear, curve through. That's kind of ugly, but you get the idea. 3. I wrote the 3. Curve on the wrong thing. Thank you. That's why it was ugly. That's much better. Good job. Y-intercept for this one? -270. It's like way down there. So clearly we're not going to graph that out perfectly. Jada, is this helping?
Yeah.
Okay. Anybody else getting something out of this? Okay, 6, 2, and 5 are zeros. That means we're going to divide both by both of those. Can I just show you this one and see, or do you want me to do this whole one? Okay. All right, so checking now. Here's number 1. There we go. So -1 is a 0. If we divide by it, we get this quadratic. That's a cubic. So -1x cubed plus 2x squared. And we factor out that x squared, factor everything. Here's our zeros. I didn't make a multiplicity chart. I should have. Let me do that right now. This is 1 and 2 and 1. Okay, we have even negative end behavior. So come up through linear, bounce off, and then back down. Any questions on that one? Okay. 2, 3, there is no 3. 4 we did last week. And then, where's the rest of it? What the heck? Well, we might be doing it anyway. All right, there's 6. There's 6. I pulled out a 2, and then we were told 2 and 5 are 0, so I divided with the 2 and the 5 on the GCF version. You don't have to do that. It's fine. It just makes the number smaller. Okay, once you do that, it breaks down to this quadratic. Factor that thing. And then that bottom line is factored form. And you'll notice we have our 4 zeros, but they're all just a multiplicity of 1. So everything just passes through nice and clean. Jada, is that good enough for that one? You sure?
Yeah.
Okay. All right, and then number 6. Here's that one. Because it was given as x squared, we couldn't do synthetic division, not on the way it was given. So long divide that. Because we started with the 5th degree, when we divide this, we end up with the 3rd degree. And here's why. I factored out an x first. You don't have to do that either. It just helps. Anytime you can GCF, it helps simplify things down. Okay? So pull that out, divide, you end up with 2 quadratics. Both of those factor. X squared minus 9 is called difference of squares. It's just x plus 3, x minus 3. Or you can square root and get the same thing. Okay, and then we have those from the other version. Okay, factored form adds an x in there. And then here's your graph. Kind of a cool graph. How'd that one go? Okay. Overall, give me a fist of 5 on using a 0 or 2 to graph, well, to factor and graph. Fist of 5 on this kind of stuff. We're going to continue doing it. We're just going to add a layer. So I think based on those fingers, I think we're in a good place to do that. So grab your notes. Let's talk about these 2 theorems. Okay, zeros of polynomials we're talking about here. First one sounds like a pretty important name. It's the fundamental theorem of algebra. Oh yeah, I remember your plan. Okay, here we go. With that, it says this. A polynomial has the same number of zeros as its degree. How many zeros does a 5th degree polynomial have? A 5th degree polynomial has 5, right? Just like we saw a squared, like a quadratic has this up to 2 for 2 2nd degree. Now here's the thing though. Not all zeros have to be real. So we've seen that in some of our work. Well, last Thursday we did, where some of the zeros were complex. Remember when it was like, you don't have to write this, but let me remind you what we saw. If we had, let's say, a cubic like that, a cubic is 3rd degree, so how many zeros does it have? It has 3. So remember we saw 1 real on these kind, and then the 2 that could have been are the 2 complex ones. So there's our 3 zeros. 2 of those were complex, 1 was real. Okay, if we scoot that up a little bit, like that, now we have the 3 that we can find that are all real. So it has 3. A 4th degree has 4, etc. Why is that helpful? Yeah, that's really what it comes down to. So let's put that. This means keep working until you find them all. Why did I write that? Until you find them all. So it's a pretty easy to understand theorem, but it's really important because it tells us how many to expect, how many to find, okay? So if you go back and look at that sheet that we were just working on, so keep your notes, I will do it for you. How many roots or zeros does this first one have? Just everybody say it. 4. Number 2, 3. Okay, and look, we found them. 1, 2, 3. How about number 4? 4. And there they were. 1, 2, because it had a multiplicity of 2. So 1, 2, 3, 4. Number 5, how many should it have? 5, and it did. It was 3 3s, 4, and then 5, right? So 1, 2, 3, 4, 5. 5 zeros. Okay, how about number 6? How many? 4. Second number 6 should have 5. Okay, and we saw that when we looked. So we know to keep going until we find them all. Let's make the note just because we ran into it just now. That multiplicity counts as repeated zeros. So a multiplicity of 3 counts as 3 of them. Okay. This next one is kind of major. So let's tackle that one. Root or rational zero theorem. Roots and zeros mean the same thing, if you haven't picked that up. Okay, here's what it says. All rational so this is real whole numbers or fraction. That's what it means by rational. So all rational zeros of a polynomial will come from, and this is where it gets kind of long, the positive or negative ratio of factors of the constant, which is just the number at the end, over the lead coefficient. Over, I should say specifically, factors of the lead coefficient. course, an example will help because this is fairly wordy. Factors of the number at the end divided by factors of the lead coefficient, which is usually a small number, so those factor lists is pretty short usually. Okay. If we want to quickly write it as a formula, I'm going to call this possible rational zeros, because not all of them are going to be that. It just says comes from rational. Sorry guys, I'm having trouble writing. There we go. Okay, always write your positive and negative out front, and then create a ratio, which is just a fraction. And we're going to say factors of the constant over factors of the LC, lead coefficient. So as a sort of little formula, that's what it would look like. Let's do an example to illustrate. This gets kind of intimidating because it looks like we're going to have to check a whole bunch. Usually you don't, but sometimes you do end up checking like 10 or 12, which is kind of a lot. I'm going to put an example right here just because it doesn't need an example box. Tell me if you can't see, but I need to write right here. 3x, let's do something bigger, like 3x to the 5th minus 7x to the 4th plus 2x cubed plus 5x squared minus x plus 24. Let's do 24. Okay. What did you say? 21. 21 would have worked. I mean, there's nothing that doesn't work. Can you see if I'm still standing here? Okay. All right. There's our there's our polynomial. First of all, how many roots will this have? How many zeros? It will have 5. Eventually, it will have 5. Okay? So remind yourself the 5 zeros. Well, let's say the rational, because I don't know if this one has complex ones. So the rational zeros will come from this list. Ready? Positive or negative. Okay, what are factors of 24? Let's just go in order. So 20, we can go in order from bottom to top. That's the best way. 1, 2, 3, 4, 6, 8, 12, and 24. Did I miss any? 1 and 24, 2 and 12, 3 and 8, 4 and 6. No, that's all of them. Everybody see what I did there? In fact, why don't you just tell yourself, since this is notes, this is factors of 24. Okay, what are factors of 3? 1 and 3. Okay, so this is factors of 3. Okay, we're not done yet. This is just creating a list. Now we need to go write out the list. Write out all. Let's emphasize that a little bit. All possible rational zeros. Okay, and this is where it's going to be like, oh, great. So I'm going to point up here. Can you just pause for a second? so you know what I'm about to do. Okay, so look up here. You're going to take 1 over 1. That's one of them. Then 1 over 3, that's another one. So 1 over 1 is 1, and then 1 over 3 is 1/3. Then we're going to go 2 over 1, 2 over 3. 3 over 1, 3 over 3. Oh, but wait, 3 over 3 is 1. So we already did it, right? 4 over 1, 4 over 3. 6 over 1, 6 over 3. 6 over 3 is 2. We already did 2. 2 over 1. Okay? 8 over 1, 8 over 3. 12 over 1, 12 over 3. Wait, 12 over 3 is 4. We already did 4. So there's going to be some overlap that you don't have to do twice. But that's going to create our list. So let's start writing our list. Okay? And don't forget that this is always positive and negative. So it's 1 over 1, 1 over 3. 2 over 1, 2 over 3. 3 over 1, 3 over 3. But this is just 1, so cross it off because we already did it. I'm just writing it to show you where it's coming from. 4 over 1, 4 over 3. Does everybody see where we're coming up with this list? Okay. 6 over 1, 6 over 3. That's just 2. So we already have it. 8 over 1, 8 over 3. 12 over 1, 12 over 3. That's 4. We already have 4. 24 over 1, 24 over 3. That's 8. We already have 8. Okay? So when I say, here's a polynomial. In fact, there's one right there. If I said go factor it, go find all the zeros, please. This is the list from which you will draw from to try synthetic division. Okay? How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Positive and negative, that's 24 different options to try. Okay? Synthetic division. You know, you start with 1. Oh, shoot, 1 didn't work. Now try negative 1. You don't have to go in order, by the way. But do you see what I mean by it? It's kind of like you might have to do this a few times, right? Okay, so think through a possible scenario. We try 1, 1 doesn't work. We try negative 1, negative 1 doesn't work. We've tried 2 times now. Okay, maybe we go to 2 because maybe we don't want to do a fraction just yet. 2 doesn't work. Negative 2 maybe does work. Now this was 5th. Now we're at a 4th degree. Okay, then you keep going. 3, negative 3. Maybe now you're like, okay, I'm going to try 1/3 and negative 1/3. Okay, and maybe you hit on one of those and now it's a cubic. So now we're at 3rd degree. Keep going. We've divided, I think I said like 6 or 7 times. Seriously. Maybe try 4, negative 4. Maybe you hit again and now you're at a quadratic. Now you abandon synthetic division and you just do your star. Okay? Tonight on the sheets, I want you to just list the possible roots. Don't do any factoring yet. Just use the rational root here and list the possible roots. I'll tell you which ones to do.
I don't know.
Okay, I want you to do this side. I'm going to call it the front side because it has your name. Only list the possible roots, nothing else. Have a good day.
You too.
Yeah.
It's actually like nice.
Fifth and eighth.
Okay,
What's
can I
up?
come in during the fifth to finish my list?
Yeah.